welcome back. I hope you all had a wonderful break and now ready to start the classes, lessons, and ready to start doing all these maths and verbs, hopefully. All right, so welcome to our pre-calculus lesson 18, which is related to identifying and applying linear functions. Already you have seen linear functions. Now we will actually, this is some extension on that. Okay, let's look at the agenda. Identifying linear functions, and from this topic is related, we will discuss in connection with from a given function and from given data. That means we'll try to connect it with the data and the functions. How do we understand that which one is linear, which one is not linear? Then some practice. Then we have some application. We have application on the linear function, and mostly we'll discuss supply and demand math today, and then we have more plans in the coming classes. Let's begin. Then we have practice on the same thing. So first of all, what is a linear and what is a non-linear function? Let's put it here. What is a linear and what is a non-linear function? For a linear function, this is the shape of the linear function, fx equals to mx plus b, or something like y equals to, let's say y equals to some equation of a straight line. That is linear. Okay, equation of a straight line, suppose twice x plus 3, something like this. This is linear, and if we write it something like fx equals to twice x plus 3, same thing I'm writing here, then it is linear. Linear. So for suppose even if we write just only y equal to x, still it is linear. Y equal to x, just only y equal to x, it is linear. So for a linear function, we have this shape, fx equals to mx plus b format. We have this shape, and some of the quantities here can be 0 sometimes, and still it is linear. And if the data is given, then from the data we have to look at if average rate of change, that means the slope, is constant or not, if the slope is same or not, which we will discuss in the examples. And for this also we have more examples in the next slide. So to be linear, just to be clear, first of all, for this is the shape for linear function. And for non-linear function, there will be some exponents, roots, x in the denominator, like that. So something like if I say, suppose 2 to the power x, or even x square, suppose x square, y equals to, y equals to 2 to the power x, or y equals to x square. These are non-linear. These are non-linear. And root, suppose y equal to root x. These are non-linear. Suppose if I write y equals to 1 by x, these all are non-linear equation. These all are non-linear equation. So this is linear, this is non-linear. One easy way to differentiate is the power of x and y. This is 1. The power is 1 here. Power is 1 here. So let's look at the next page, which we have written here once again. So the average rate of change means delta y by delta x, which is slope y by x, and it has to be constant, or the shape will be y equal to mx plus c, or fx equals to mx plus c. These are more examples. See, all of them are linear. All of them are linear. 3x minus 2 minus twice x. So this minus sign, these numbers, it's not a problem. Our main thing is you have to look at x, what is happening with the x. That's the most important thing. X, fx equals to minus 7, this is also linear. Then 2 into x plus 1 minus 3, fx equals to, it looks like a big thing, but you see the power of x is still 1. And this y, fx means y, so y is also 1. So it doesn't matter actually. The numbers, all the other numbers are just some constant numbers, so it's not a problem. But here, the power of x, there are some exponents, some root, x in the denominator, x in the exponent, some modulus sign, and then some x is in the denominator here. So they are non-linear. They are non-linear, and this is linear. Another way to understand what is linear and what is non-linear is if you are visual, if you want to understand it visually. If you graph anything linear, your answer will come some straight line. Okay, answer will come some straight line. Linear means your answer will be straight line. Then it is linear. Non-linear means if you draw the graph of any of this, if you draw the graph of the non-linear function, then the graph will not be straight line. It will be somewhat curve or some other things is related to that. Something like this, or something like this. So this will not be straight line. That's the thing. And here there will be straight line if you draw the graph. So to be linear, our power of x, they are 1, and or some constant number. It can be, because y equal to mx plus c. If x equals to 0, then c is a constant number. So this is also a form, this is also a shape. This is y equal to minus 7, which is actually a horizontal line if you recap it from your previous lesson. And non-linear is this, as I said. So non-linear means you will have some root. The same thing is written here. Non-linear means there will be exponents, roots, x in the denominator, etc. This kind of thing will be in the non-linear. Non-linear means what? Non-linear means if you draw the graph, it will not be linear. It will not be line. It will be some curve. It will be some zigzag, something curved. Okay, it will be something like that. So which one is linear and non-linear function here? Find it out. Suppose 39 number, is it linear or non-linear? 40 number, is it linear or non-linear? Which of the function here represent? Let me move myself here. So I'm in the picture of myself, not myself. I'm not moving myself in my computer screen. Okay. So find out which one is linear, which one is non-linear here among all these functions from 39 to 62. And in the meantime, I'll go to Dhaka and come back, because there are a lot of questions, so you will need a lot of time. Okay. All right. I hope you have given some try at least. Oh, I don't. This is not what I wanted. This is the book actually. Okay. So if you look at all the functions, there are a problem with most of the functions here. See, x squared. That means it is not. Let me give some. The problem is here, x squared, so it is not linear. X squared, not linear. X squared in the down, not linear. X in the down, denominator, it is not linear. Modulo sign, not linear. Square root sign, not linear. X in the downside, it is not linear. X in the downside, it is not linear. And finally, you have got one which is linear. Because you see, this is a straight line equation. Straight line. Then here, this one, not linear. This one, not linear. Problem is where? Problem is here. Not linear. Not linear. Not linear. X in the denominator. Not linear. Not linear. Square root. Not linear. Square root. Not linear. Not linear. Square root. Not linear. Again, square root. Also x in the denominator. Square root of negative x. Oh my god. Okay. But we have actually for some of the values we have the graph. And t is in the denominator. T is the variable here. T is the variable, x instead of x you have t here. Then z is here square root and again in the denominator. So only answer is this one. Okay, only answer is this one, which is linear, and all others are non-linear. Okay, so only one is linear here. Then suppose these are given. So how do we know that which one is linear? Suppose this box, is it linear? This box, is it linear? This box, is it linear? How do we understand which one is linear and which one is not linear? The rule is, let me explain it with some simple data first. Let me explain it with some simple data so that suppose if I have 1, 2, 3, 4, if I have this side 5, 10, 15, 20. This is x, this is y. And then x, y. 1, 2, 3, 4. This is suppose 3, 9, 12, 15. Suppose these are my data. These are my data. This set and this set. You have to find out this is linear or this is linear, or both are linear, or both are non-linear. So look at this. For linear, our average rate of change has to be same. Has to be same. And in this side, that means average rate of change. Actually, the another way to explain it, to describe it, is change the common, change the difference. Change the difference between every consecutive term. Difference. The difference is 1, 1, 1. In this side, just increment is just 1, 1, 1. That means this side always, all the gap is 1, 1, 1. This side gap, 10 minus 5 means 5. 15 minus 10 means again 5. And then this is again 5. So you see that difference is same everywhere. Difference is same everywhere. That means it is linear. Okay. Now, just to confuse you, I will give you one more extra value, 4, then I will give you 6, and then I will give you 30. And here the difference is 2, here the difference is 10. But if you take the ratio 10 divided by 2, again your answer comes 5. That means still it is linear. Do you understand? It means what? It means I just did not give you 5. For 5, one value is hidden here. One value is hidden here. For 5, it is 25. And actually this rate is still the same. Change is still the same. 2 minus 1, 1. 3 minus 2, 1. 4 minus 3, 1. 5 minus 4, 1. 6 minus 5, 1. Just one value is hidden here. So if sometimes some value is hidden, you can actually understand that by taking the, okay, what is this difference and what is this difference and what is the ratio. And for ratio, you know, y divided by x, always we divide this divided by then this 2. We will get that 5 again. Here actually what? 5 divided by 1 means 5. 5 divided by 1 means 5. 5 divided by 1 means 5. What we are doing here is actually we are doing the same thing as y2 minus y1 divided by x2 minus x1. That means delta x divided by delta y. We are actually, delta means change in, change. Change means y2 minus y1 divided y2 minus y1, or here x2 minus x1. Change. Change. Suppose you go to a market, you bought something for suppose 60 taka, then you give them 100 taka, they will give you change 40 taka. 60 minus 100, 100 minus 60 goes to 40. Change, difference, difference. Now look at this side. Here 1, then 2, then 3, then 4. That means the difference is same here. Then 3 minus 3 and 9, difference is 6. 9 and 12, difference is 3. Then 12 and 5, difference is 3. 12 and 15, difference is 3. So you see there is a problem with these two values. Here actually 1, 1, 1, all the same. So you see, if you take the common difference, if you take the ratio, then it will not be same. It will not be same. If you take the ratio 6 divided by 1 equal to 6, 3 divided by 1 equal to 3, and 3 divided by 1 equals to 3. So for this value it comes 3, and for this value it comes 6. Basically, the ratio is not same here. Delta y by delta x is not same here. So it is not linear. This data set is not linear. This data set is linear. To be linear, so just to recap, our delta y divided by delta x will be a constant number. Suppose this 5, 5, 5. Constant number means one number. One answer will come for all of them if you take the delta y by delta x. Let me show you from this data. Let me show you one very interesting thing. Suppose if you take only this value and just you take this value and delta y by delta x, you want to change check what is the ratio. You will see that no matter which value you choose, your this y delta y divided by delta x will be same. See this. This is 30, this is 5. So 30 minus 5 equal to what? 25, right? 30 minus 5 equal to 25. Then this is 6, this is 1. 6 minus 1 equal to 5. 25 divided by 5 equals to 5. See, average rate of change is constant. No matter which values you are choosing, if you take their ratio of change in y divided by ratio of change in y and change in x, then it will always be a constant number. Then it will always be a constant number, always be a same number if it is linear. If not same like this, then it is non-linear. So this is how we can understand which one is linear, which one is non-linear. A very easy way to understand is their gap is usually same. If the gap is not same, then you have to look at the other side. Okay, if in the other side also gap same. Gap means difference. Gap means difference. So this way you can. So okay. So now if you look at this value, and this value, what is the change? You can just have a look. So this is 0. Let me you can use the calculator also. So 0.12 minus 0.09, so it is 0.03. Let me write it here. So 0.03 for these two value, 0.03. Then you can say for these two value also. Then 0.16 minus 0.12. 0.16 minus 0.12. Answer is 0.04. So if you take these two value, it comes 0.04. So already we can see that their gap is 1, here gap is 1, but this gap is not same. Gap actually increased, and gap actually increased. This gap actually increased already, because this side is 1, 2, 3, 4, 5. So this gap cannot increase now. Gap can increase if the other side also increase. If the other side, like that one. So suppose if I jump from 4 to 6, then other side can jump. One side cannot jump automatically. This is 0.3. This also must be 0.3, 0.3, 0.3, 0.3. Or everywhere, this difference has to be same now, because this side is different same. Then it will be a linear. So our conclusion is this is not linear, because if you take the difference, 0.12 minus 0.9 is this, and this is 0.04, which is not same. They are different. Okay, now look at this one. 2000, 2001, 2, 3, 4, 5, 6, 7, 8. That means this side gap is same everywhere. So this side gap is same. So that means now this side also gap has to be same. Okay, now let's check. 31.1 minus 27.9. Answer is 3.2. Answer is 3.2. 3.2. So these two gap answer is 3.2. Okay, now 35.9 minus 35.9 minus 31.1. This is 35. So this is 4.2. Then this is 4.2. I think already you can see that this is not same. 4.2. This is not same. Yeah. In this side gap is 1. Change is 1. 2002, 2003. That means what? 1 year. 1, 1, 1, 1. So this side also has to be same number. 3, 3, 3, 3. Or 3.2, 3.2, 3.2, 3.2, like that. Or 4.2, 4.2, 4.2. One number. It cannot be like different numbers. Okay. So this is also not linear. This is also not linear. Now look at this. What is the change? 20, 30, 40, 50, 60, 70. So the gap is 10. Same gap. 10 means here the gap. You have to look at if the gap is same everywhere. If it is not same, suppose sometimes it can jump just to trick you, then you have to look at the other side. Other side must also jump to get the same ratio. Okay, so now there is no problem here. This side 20, 30, 40, 50, 60, 70. That means same number, same increment. Now look at this. If this is also the same, 47.5 minus 50. Answer is minus 2.5. Minus 2.5. Look at this. Actually, I am always subtracting this number minus this number. Second value minus first value. So it is minus 2.5. Okay, now 45 minus 47.5. Answer is minus 2.5. Then 42.5 minus 45. We can see that this is same. So now we have to look for the other values if they become same. 42.5 minus 45. Answer is 2.5 minus 2.5. So here also answer is minus 2.5. And actually for all other values, if you do the calculation, 42 minus 42.5 and 40, the gap is minus 2.5. Already you can see. And this one also 37.5 and 40 gap is 2.5 and minus because the. So you see this for this this box for these data sets, our this side change and this side also change is always same. That means our ratio will remain same. Change in y divided by change in x is same here. That means this box is actually linear. This box is linear. These data, they are linear. And you can see this side and this side, both sides, they are same. Or you can use this value also, y2 minus y1 divided by x2 minus x1. And these 2 points, 1 point here, 1 point here. If you do the calculation, y2 minus y1 divided by x2 minus x1, then you will see minus 2.5 divided by 30 minus 20, that means 10. So 10 will come. And always the ratio will be same. If you use this value, this x comma y is just simply this value, 20 comma 30, 20 comma 50, 20 comma 50. So the same value here. So that the task that we have done this side is actually same here also. You can do the same for this value also because they are same. This is just x comma y written in order. So average rate of change will be constant. Constant means some fixed number. For example, in this math, fixed number is minus 2.5. For this math, fixed number was minus 2.5. Some fixed number. Number can be different. It can be 5, 10, minus 0.5, 0.2, but it will be one fixed number. It will not change. It will not vary. Then it is linear, or else it is not linear. Okay, so this box is only linear. These are for in-class practice. So why linear function is important? Why do we care it? Because we can use it in our real life situation. In many real life problems we can solve by using this linear function. Newton's second law of motion, F is equal to ma. Those who studied physics, you have seen this. F is equal to ma is very famous formula there. So F is equal to, or also in our regular life, in some part of our class also we have this kind of thing in the application math, of course. Then circumference of the circle, c is equal to 2 pi r. This is also linear. Then temperature and crisp and per minute, so they have some linear relationship. This kind of thing, all of them have some linear relationship. Let me explain this a bit. Suppose, how do we know that this is linear? See, c and r, only these two is the constant. That's why it is linear. You can change it to our regular thing. Suppose y equal to 2 pi x. So that means what? It is linear. 2 pi, that's just a number. We don't care. This number can be different, can be 10, 20, 50, minus 10, minus 0.5, root 2. Here you can replace it by any number. Of course, not for the circle, for some other linear function. I'm just telling you that all of them actually shows the shape of linear function. Here, this is some constant. This is some variable you can put instead of this. Suppose x. So 0.25 x plus 40. See, this is linear now. Height of some human being, people, the femur length, and this is the bone in our leg. So this femur length and then height. So and then we can actually based on that femur length, and we can actually find out our height, because our entire height is actually have some relationship with our bones, a small part of the bones. If someone is very tall, all of his or her body's bones will be little bit taller. So then because then it eventually it will make that guy tall. So you can see we have more examples in the next page. See more examples here. Payment for a job is like that: salary, wage, then cost, NYC, New York City takes a rise during the rush hour. I mean, the amount of money you have to pay there is this. Here miles, M is the constant here. Then Fahrenheit to Celsius, degree Celsius conversion system. All of them are linear. All of them. So you can see in our everyday life we have a lot of examples where we use the linear functions to deal with them. We have one math here, which is from example number 5 from our book. Page is so the supply and demand of a mobile phone is a function as a function of price is given sp equal to this and d of p equal to this. Supply and demand. Supply means the amount of things that you have in the market, that is the supply. Demand means how many people wants it, that is the demand. That is the demand. So you see what happens actually for some supply and demand. Suppose you want something, all the people, we need shirts, pants, or clothes in general, dresses in general, and always there is some balance in the market. If the factory produces too much clothes, then people will not buy it. I mean all that clothes, then that is a loss for them. If they produce too less clothes, then people will be like, in the market they will go and they will see like most of them is sold out. So the companies, they always try to balance it. They have to balance what is the demand in the market, what is the demand in the market, and how much they produced already, how much they have to produce. So that kind of thing. So supply means amount of product, and demand means how many people want to buy it. That's the supply and that's the demand. Now equilibrium means when the supply and demand is same. Supply and demand is same. People goes to the market, they get the clothes, they buy it, there is no shortage or there is no excess. This is called equilibrium. Equilibrium means there is no short, there is no excess. That is called the equilibrium. So equilibrium means balanced. It is balanced. Supply equal to demand, that means it is equilibrium. Equilibrium price means at which price. There is another interesting thing about this equilibrium price. Not only supply and your demand has to be same, your equilibrium price also actually matters a bit. And that's what is that? And what is that? Suppose if someone sells anything, suppose this calculator is 500 taka, and if they say like this calculator, if they start selling it 600, 700 or 800 taka, which is 300, about 200, 300 taka more than its regular price, then people will not buy it that much, because they know that this calculator price is regular price is 500, and they will not buy this calculator. They will go for something else, or they will try to minimize their demand. So if the price of the product goes high, then actually there is less demand for the product. People do not want to buy it. Again, the same calculator, if they start selling it just only 300 or 200 taka, same calculator, then people will think like, oh my god, I bought it the other day for someone, I bought it, or I have seen someone is buying it by 500, now it is 200, let's grab one. Even if people have one in their home, they will think like, okay, the price is so low, then I should buy another one extra, because if my the one that I have in my house is not working, then I can use this one, because the price is so low, then people will start buying it too much, and then there will be shortage in the market again. People will buy it too much because the price of the product is so less. And what will happen for the company is, company will not make profit from this calculator then, if the price is too less, because that's not why they make this calculator. They want profit. 500 taka is their profit and the balance price, suppose. So if they sell it 200 taka, although many people are buying it, but the company is not will not get any profit. So there is some kind of interesting things going on in this market, with the price, with the product, with this supply, demand, all these things. Mathematically, actually, we can analyze them. Mathematically, we can analyze them. This is one example of that kind of math. Suppose you already have the function, supply function is this one and demand function is this one. Supply depends on this equation, demand depends on this equation. Now, how can we find out some equilibrium? So to find out, yeah, this is what I said. We will go back there. Because company want to make profit. Profit. If the price is too low, then people will buy, and then there will be like shortage. Shortage, not enough product. If the price is too high, people will not buy it. Too much product in the market, then company will not make the profit. So company also needs to find out the equilibrium for their product. To find out equilibrium means when supply and demand is equal. That means people are buying it and they are also making the same, roughly the same amount of the product, they are also making. So equilibrium, to make the equilibrium, we have to write supply and demand, they are equal. Supply and demand, SP equal to DP. That means we have to write this equals to this downside, minus 15p plus 2850. Let's get some space. Minus, I can use actually minus 15p plus 2850. I mean, I can use some the pen. You can use less thick or just simply thin pen actually. Okay, so we have to write this equal to this. Why? To get the equilibrium. Then you can see that the 60p minus 900 minus 15p plus 2850. Then 50, this and this you can bring in one side and you can solve it. If you solve it, you will get p equal to something. P equal to 50. P equal to 50. So that means if the price is $50, then actually you come to the equilibrium. If the price is $50, then you come to the equilibrium. And if you put 50 here, in the next part, like this, S of 50 and D of 50, then you will get 2100 forms. That means that company needs to produce 2100 phone to get their maximum profit, because they will have at that time supply and demand is same. Let's repeat it. So to get the equilibrium, we have to equate supply and demand function. Supply equal to demand, then it is equilibrium. Then you solve for which price, for what price this equilibrium comes. Eh, in this math it is 50. If you solve this equation, then you will get 50. Then you put 50 back in the question, then you will get the equilibrium quantity. Quantity for supply needs to be what, or demand is what. It will be always same, because at equilibrium supply and demand is same. And then you can actually, we can do this more part of the math like that. This is like find where the supply is greater than the demand. Supply is more, demand is less. There are more things in the market. Supply. This means what? Supply is greater than demand. It means there are more things in the market than what you need, or than what you want to buy. Huge thing in the market. That means supply is more. That's why you can set it SP equal to dP. Then supply is more. In that case, what happened here is P is greater than 50. That means price is greater than 50. Why? This actually you can, if you solve it, then you will get this equation SP. SP, for SP you write 60. Let me write it here. 60P minus 900 greater than dP. dP means minus 15. P plus 2850. Now if you solve this equation, solve this one, then you will get 50. P is greater than 50. Actually the same thing you are getting. This is P equal to 50, but here you have greater than sign, so it will be greater than here. So actually basically the same thing. What it means? It means if the price is more than 50 taka or dollar something, if the price is more than 50, then there will be more supply in the market. People will not buy it. It means that. It means because 50 is the equilibrium price, if your price is more than 50 now, then people will not buy it. This is what it means. So it means like find where supply is greater than demand. That means the answer is if price is more than $50 or 50 taka, whatever is the unit here. Mobile phones as a function. Of course, it has to be $50. It has to be some dollar or some pound, because 50 taka, by 50 taka you will not get any mobile phone anywhere. So this is the condition. If you are wondering how to solve it, actually you can send this 900 this side, 15p this side, then it will be 75p. This will, if you add them, 2850 plus 900, then divide it by 75, you will get that number. Then graph, see the graph, what happens in the graph? This is our demand function, this is our supply function. And at equilibrium, this is the equilibrium. From where this two line comes? This line comes from these two equation. This one, from this one, this is supply function. You will get this line, and from this one, you will get this line. You can say, sir, we have never seen this kind of thing. From where you are getting this? Actually, in your mind, you can just think this is y, and this p means this is x. So what is this? Y equal to 60x minus 900. This is some equation, right? Equation of a straight line. This is also y. This is just x. Just in your mind, you can think like that. If you are like, oh my god, these are some crazy alphabet here. Basically, they are straight line. All of them are straight line. And they will intersect at a point. That point is equilibrium. that all the companies, they are looking for where is this point for their maximum profit. Eh, for their maximum profit. So all the companies wants this point where these two line will intersect. Where is their maximum profit? Okay. So this is how this graph works. This is, if you draw these two equation, then you will actually get this. And the answer is actually same. You can see this is the 50, this 50, and this 100. In the graph, you will automatically see these two line will intersect at 50 and 200 because they will fit. They satisfy the equation at this point. Both of these two functions. Yeah. Both of the two functions. So this is the equilibrium point, and this is most important thing for this kind of supply and demand related question. We have more practice, same setup. We have more maths on this. Suppose now the question is this, then how can you find out equilibrium price, and then what will be the demand if the price is $500? So you can put $500 here and find out the demand. We have actually done all this maths here. So 1200 AC is then the same type of maths. We just have done it once again here. You can try this math and check if they are same or not, or then we can discuss it during the class also. But supply and demand related concept is one of the important thing. Another thing is coming up. Another thing we will discuss in the coming class, because they actually connect most of the concepts of our linear function. So they actually connects it. So you give a try. About this maths. Similar to the previous math. That is similar to this math. Similar to this math. Suppose here you can say, sir, this is not same. This is different. $500 is, so what I will do? $500 is the price. So you put here in the price. Then you get that. What is happening in $500? If you are interested, this is not related to this math, but what is happening in $500? If you are interested, you can actually look at the graph, and you will see that $500 is here, and this is not equilibrium. $500 is not equilibrium. $500 is too much for that company. Equilibrium is here. Equilibrium is here. So $500 is not equilibrium, and actually you can see it here also. Equilibrium price is $380, which is here. $380 is here, somewhat here. Yeah. So this 500 is too much. And how do you know? You know it from the equilibrium price. If you write this equal to that, then you will get the equilibrium price. Now, suppose you can say, sir, then why you are telling us to do the $500 price? This is just a question. We can say find out the price or demand for $200, for $300. You will just put it here for this P. You can. If I say find out the demand for $1,000, so you'll put here. If I say find out the demand supply for $500, so you'll put it here. Okay. But finding equilibrium price, equilibrium thing is still the same. You will write demand and supply equal, then solve it similarly. And then we have this kind of practice thing, practice maths 25, 26. This two math is related to identifying linear functions, and this two math is related to the supply and demand math from our book. Of course, these are from the PDF book. Yeah. So all the best, and see you all in the class. Thank you very much for watching this full video. Bye bye.